Hi, in this lecture we will understand trapping rainwater problem. So this is a kind of medium to hard, you can say, is a kind of problem which is generally being asked in interview questions, and this question is becoming a common interview question nowadays. So it is better to understand what is trapping rainwater problem. So in this data structure and algorithm problem, you will be given an array like this. I have just represented this as an array, and this array will be representing the height of the walls of the, you can say, container which will store the volume of water. So as you can see, you can assume this is a container. It has certain walls, like this is a wall, and here a wall, and here a wall, and rest are just void container. So this 2 represents that the height is of 2, 1 and 2. You can assume any unit, either a meter or brick or feet, anything. And this is 0, so here no height is there. It's a kind of 1 unit and 1 unit. So again 0, so again it's a 1 unit and it's a 1 unit. And then 3 is the wall, 1, 2, 3 is the height of the wall, and then again a 0, and then again a 1. So the thing is, the key point to note here is that whatever water it will store, it will be the lesser of left hand side and right hand side of the walls, maximum height of the walls, which will be coming at that point. So suppose if I talk about this part, then you can see that the height here is 3 and height here is 1. So whatever water which will be coming out here will be drained off, and also the water which is coming out here will also be drained off, because the right hand side wall is having only 1 unit of height, so it will store only 1 unit. And similar goes for this part. So this is the volume of water which will hold this and this, and whatever the water which is coming at this point will be drained off, because the height is 2 here. So we need to compute the maximum wall height which is coming at that index at left hand side and right hand side, and on the basis of the maximum height we need to compute the volume of water on the basis of minimum height of right hand and left hand side. Assuming if I go with the algorithm, so we need to calculate at each point, you can say at each index we need to compute the maximum left hand side, and at each index we need to compute maximum right hand side, and on the basis of minimum of left max and right max we need to compute the volume of water. And what volume of water we need to compute? Suppose wall is coming at this point, so if 2 height is there, then 2 height is the height of wall, so we should not count that. So on the basis of that we need to deduct the wall height also at that point, so we need to deduct this. So somewhat the algorithm will work like this, that we will calculate the left hand side maximum wall at each index and right hand side maximum wall at right index, and we will take the minimum of left hand side and right hand side wall which will be coming at that particular index, which is this, and we will deduct the wall height. So this is the exact algorithm which will be working. So I created a main method and called this method to print the trapped water volume, and I passed this array, the same array I passed, just to demonstrate you. If you see the volume of water it will hold is this 1, 2, 3 and 4, and here it is 5. So total number of units which will be coming out here in the output will be 5. So let's see. So this is the main function in which we will write the code. So let's assume that the volume is, initialize the volume as 0. So now what we will do, we will compute the maximum height left hand side and right hand side and store it in a different array. So I will create an array, I will call it as left max and initialize with int, and let the size be the array of given length, so it will be new int, and this will be this, n is the size of the array. Similarly we need to create one more array which will store the right hand side maximum value at each index. So we have created an array to store left hand side maximum and right hand side maximum. Let's initialize temp value, which will be giving the minimum, or you can say max value, let it be, which will store the maximum left hand side and right hand side at each point. So I need to provide, let's initialize with min value of integer, and now I will iterate from left hand side, that is from I is equal to 0 till I less than the size which is given and I plus plus, basic iteration. If, and one more thing, if the maximum value which we are taking at each point, if it comes out to be lesser than the array at index I, then we will manipulate that max and put it as array at I. That's it, and store the maximum at each point which is coming for that particular point. So I will store in the left array, that is left max at I is equal to the max. Similar code will go for the right array also, but the basic thing is that iteration will be from, not from left but from right side. So again I will then change this max value to min value, because again we are doing iteration from the end till start. Since we are doing from end, I will initialize it with n minus 1 and I will go till I greater than minus 1. I've seen people doing greater than equal to 0. It is better to go with greater than minus 1 and reduce it every time the I value. And now the same computation I will do here. If max is less than array at I, then change max to array I and put the right hand side array as max. So we have initialized R max, so it's R max. As you can see, R max is there, L max and R max. Now we are having both left hand side maximum arrays at each point and right hand side maximum while denoting at each point. So we need to just calculate the volume. So I will go with the volume part. So I will call from int I equals 0, I less than n, I plus plus, int delta volume you can say is equal to math dot minimum. As you can see, we are taking the minimum of left hand side and maximum side array data at that point. So left hand side array data is L max at I and right hand side array data is R max at I, and reduce with the wall height. At suppose the wall will also come. Suppose if it would have been like only one wall, this would not have been there. Let's suppose that this is not there. Then here the total volume, and let's assume I'll put here one more wall. So the volume which will be coming at this point is only 1, because this will reduce the volume, because wall volume will become 1, and so from 2 it will reduce this wall height. So that is the only thing which we are doing right now. We are reducing the wall height here. So I will reduce the wall height if it is coming at any point. So this is the delta volume. If this volume comes out to be positive integer, it can come negative, because there are chances that at suppose this is height 3, and if you calculate the volume at this point, it will come negative. So in that scenario, it is better to go by checking that if it's positive or not. If it is only positive, then only the volume will be calculated, because volume is a positive thing. So we will just calculate volume and compute that volume and add it in the volume variable which we have provided in the starting. So after this iteration, we will simply print out the volume of water in container is simply print the volume. So let's see. In this scenario, it should come out as 5 because it is holding 1, 2, 3, 4 and this 5. So if I run this, run as Java application, see volume of water in container is 9. 9 why it is coming, there might be, okay, we have taken maximum value, it should be min value. Now let's again run this, volume is coming as 5. So this is what our problem was. Now let's go with some other problem also, like if I put 0 here and if I remove this part and again this part also, this part also. So as you can see, the total volume of water which it will hold can be represented as this. Again here it will be 1. So you can understand that total volume of water which it will hold, this part will also get drained off, this will also get drained off, because wall is only at this point and this point. Though wall is at this point, but it will not be counted because from here the water will be drained off from the last. So as you can see from the end, if I go, so from this point only one wall is there, wall of 1 unit, so water will be drained off. So we are having 1 unit, 2 unit, 3 unit and 4 unit. So it should give 4. So let's run as Java application, save it. Volume of water coming out to be 0, 1, 2, 3. 1 volume, 2 volume, 3 volume, 4 volume. Okay, we have not changed here. So now let me run it. So this is coming as 4. So this is about the water trapping problem. Compute the left max at each point, compute the right max at each point, and take the minimum of left max and right max and reduce the wall height. You will get the output. Thank you all for watching the video.